See my presentation.
Yeah, it's visible, fine.
Perfect. So, good afternoon, everyone. Good
Be-
afternoon to my.
yeah, before that, let me give a brief intro about it.
Oh, please go ahead, sir.
Yeah, yes. Okay, very good afternoon. Very good afternoon to this webinar on process of innovation development and technology readiness level and commercialization of lab technologies. And this is the initiative of the Ministry of Education, Government of India, which has established innovation cell in our institute. The primary objective of this cell is to encourage, inspire, and nurture young students by supporting them to work with new ideas and transform them into prototypes. So today we have our guest, Mr. Himansu Pandey. He is currently working with NITI Aayog, Government of India, as a young professional in Atal Innovation Mission, Delhi since July 2019. So he has completed a BTech in Electronics and Instrumentation Engineering in 2016 from SRM IST. So he is one of our alumni. We are proud to have you here as a speaker, Himanshu. And on behalf of the department, I welcome you for the session. Please take over the session.
Thank you, sir. Thank you for very kind words. Good afternoon to all my teachers, professors, faculties, and also dear students who have joined. Sir has already given introductions. I'll just skip directly to the main content of the slides. But before that, I'd just like to add that this is supposed to give you a general overview of what does innovation mean, what are different stages of innovation, what are the fallacies that you must account for before you begin in your journey, and wherever you are on your journey, what are the different things that you're probably encountering or can encounter or should probably account for if you have not already. So see it in that light, see it as a learning, and also at the last I'll try to add a few things about what we at Atal Innovation Mission / NITI Aayog do. Atal Innovation Mission is a small department under NITI Aayog. NITI Aayog is a larger body. Atal Innovation Mission is considered as the central ecosystem body for innovation building in the nation. So we have a lot of different programs through which we address different aspects of innovation, right from schools all the way to high tech enterprises. So there's different things we do. Today's presentation, like I said, is very focused on why innovation, what is the different components of innovation, and different challenges of innovation. Before that, for a begin, please let me know if the slides are changing. Okay, perfect. Is the slide changing, sir?
Yeah, yes, it's fine.
Oh, great. So why even bother about innovation? So if I have to just throw a simple data point at you, I would say India is building cities at a massive pace. Like we are building a new Chicago every year. That's how fast we are going. And from the likes of it, we are probably going to have a population of 70% living in cities by 2050. That's a massive population, and for a small constrained area, it is always important that you utilize your resources to the max. You innovate to utilize your resources to the max. So that is why we at government are very excited about innovation, and we want to support innovation at different levels. But government alone can't be doing everything. Like, it's a private sector that largely drives the innovation. So that is why we try to bring in the ecosystem part of things. We try to do different things that enables innovation. Keeping on the same spirit, there are different challenges with innovations in local bodies or with cities itself. There is a problem in identifying problem itself. There is a problem in sourcing solution. There's a problem in identifying where does the best fit solution lies, and then there is a problem in onboarding and deployment. This I'm trying to tell you this, trying to show you the slide so that you understand that the government itself is trying to tackle these issues at different levels, and there are different components for you to intervene in. So it's not just that we have figured it all out and we know how to do. We require the initiative from the industry, from the private partners, from innovators like some of you would be in future, to take this forward. To give you a brief, oh sorry, I think I jumped a lot of slides here. That's okay. To give you a brief overview, how do we go about things, like how do we go about identifying solutions or mapping them? Here is a brief overview of, let's say, a problem that we face in government. Let's say if the challenge is how do we reduce plastic, then we look at all the different aspects of reducing plastic. Now how is it for you as a student? This is how you look at a problem and break it down. So even if you are, let's say, very passionate about reducing plastic and you want to work on it, that's one starting point for a lot of us. So to break down further, you should probably go deeper into understanding each components of it. Like, do you want to reduce the demand? Do you want to find a supply alternative? Do you want to manage the logistics of things? Do you want to, let's say, in plastic itself, do you want to get into process and recycling? And finally, do you want to get into something else altogether? I'm really sorry for the slides. It might be moving around a bit. Right, sorry. So with that in picture, you would see the slides that you see over here will give you a brief overview of how, again, apologies, this is misbehaving. This is how we go about first, mapping down and narrowing your vision of what you want to do. Then let's say, for example, NV Green someday begin by saying, we want to reduce demands of plastic, but you want to do it on a short-term basis. That is smaller aspects of things like water bottles, carry bags, etc., which is one-time use. There are bigger companies, for example, Agringenium, which is making products out of hay or waste, agriculture waste. These could be packaging material, this is panels and all these things. So these are medium term impact things. So you first and foremost thing for you to do is to figure out what your intervention is going to be, in which area it's going to be. Once you've figured it out, do the landscaping. Don't start blindly ki, okay, this is nobody's doing this and I'm probably the first person to do it because there's no buzz in the market, which is more often not true, because somewhere in the world would have done that. And see where you fit. See, draw this value chain for every problem that you're going with and see where you exactly are intervening and actually provide a solution for. Similarly, here's the second problem that I've tried to show you the same type of understanding. For example, stubble burning is a major issue, at least in Delhi and surrounding area, all of North India in fact, where a lot of stubble is leading to a lot of air pollution. Now, if I look at this value chain and if I look at the entire problem, you would find that there are no long-term solutions, no long-term solution in detection, alternatives, managing logistics, and so on and so forth. So an exercise like this tells you the places where you see X is places where the opportunities lies. So even let's say you want to get into stubble burning, then do your study well, do this landscaping so you know where the gap in the market is, where you can add the maximum value, and where do you see the least competition. That will tell you which direction to take forward to. Once you do that, there is so many factors to intervene. Even with, let's say, a small component like smart city, there are so many factors to it where every aspect can be a startup in itself, or solution can come from a startup itself. For example, if you have environment, your energy saving itself can be a aspect where a startup can get involved in. So if I look at the innovation ecosystem from a government's lens, this is how we normally see it. We look at a problem and we look at different aspects of it, and then we look at different sub aspects of it, and we try to find solutions, or we try to promote startups which work in these particular individual sectors. And this is why the slides that I was telling you before is very important. If you have your vision laid out, or if your focus laid out, you can easily be adapted, or you can easily find a market for it. With that forward, I'll skip this for you now. What really happens, like how does a startup grow? So what you're seeing on the screen right now is famously called the two valleys of death. That they are called two valleys of death because this is where the startups die. That is this is where most startups fail. So if I have to begin by saying this, that the entire life cycle begins from basic and applied research and goes all the way till full commercialization. So when you're doing a basic research, that is, let's say if you're in a college and you want to do, if you're making a particular product or a particular technology, you should begin with your basic research, where you apply all the knowledge that is available to you, around you, to see if this can find a feasible solution. A lot of startups are usually okay at this step, but when they get to a proof of concept or prototyping, that's where the first value of death arises. That's where you see the first early stage of value of death. This value of death arises largely because of two large factors. One is lack of funds and lack of mentoring. Lack of funds are required in this stage, because if you don't have the funds, you cannot build a prototype. And similarly, if you don't have a mentorship, you don't know where to go for a prototype or getting that money. So both money and mentorships helps you come out of this first value of death. And once you develop your technology further, you go from basic research to applied research, wherein you are actually deploying solutions. You will find that you are okay till that point because you have gotten enough funds to get through it. You can also raise money from different places. But after that, it comes the second value of death, where your product is ready, your prototype is ready, but now to scale it up and take it to a market level where you can compete with the big players is the second value of death. And the second value of death, or commercial stage of value of death, is where a lot of startups usually fail to scale up. They are good products, but they do not find a market. There could be multiple reasons. It could be marketing, it could be different aspects of product itself, it could be user experience and all that. But largely, the commercial stage of value of that leads to the second stage of failure. And to mitigate it, you need a lot of capital, or a lot of we call it accelerators in our terms. First one is addressed by incubators, second is addressed by accelerators and large funds, which can give you money to open factories or to open production units, to spend extra money on marketing and all that. So these are largely two valleys of death that we have in innovation ecosystem or innovation life cycle. Acknowledging them is very important so that you know, and wherever you stand at this point in this scale. Also, I'll get you into an example after this so you understand this better. It is for, if you are a startup or even if you are starting off, remember that these are there, these stages exist, and this is where most startups face challenges in. So you know where to go. For example, if you're an SRM or if you're in colleges which have incubators, one of them is SRM, you can easily mitigate the first value of death, which is early stage value of death, just by going to an incubator, because they can give you the basic fund you require, they can give you the mentorship that you need, and there are a lot of government programs also that try to address the first value of death. The commercial stage of value of death is little tricky, but again, if you reach there, you would have figured out contacts, and even a lot of times the incubators that have grown into an accelerator. For incubator, the next stage in accelerator, where they connect you to people who have money and resources and connections. That stage will enable you to get out of commercial stage of value of death. But I'm assuming the early stage of value of death is far more important. With that, let me just quickly jump into the same thing but with examples. Like I said, this is it's a whole life cycle of development. So there is a very famous scale in innovation ecosystem. It's called TRL. It exists in all scientific developments now. This was developed by NASA. It's called Technology Readiness Level, which says ki with these 9 steps that you see on screen, you can practically categorize where do you stand, and then call yourself with that TRL level. And this in a way is also a guideline for you to progress. So let's say if you're starting off now, you start at level 1. Let me give you an example here. For example, if you have to make jet engines, let's say Chevron nozzle jet engines, which are used in, let's say, heavy lifting airplanes, or most of the times it's either commercial jets or heavy lifting aircrafts. How do you begin with this entire cycle? The first stage which I talk about is called basic principles observed and reported. The basic principle would be the fluid physics, that you study how how does the CFD analysis work, how does your air flow through, let's say, a turbine channel and all that. So that basic research on fluid physics is absolutely mandatory to even begin the process, and that becomes the foundation stone, or the level 1, or what we call TRL1. So if you, let's say, someday you aspire to make a jet engine, this is where you begin. Once you have this, you go to next stage, which is technology concept or application formulation. Now you have figured out that fluid dynamics works certain way, but you have to apply it. That application is done through, let's say, you do either a simulation, you draw it on your devices, or you do it on your paper. That doesn't matter. But here you are trying to figure out, okay, this is how air moves through this certain channel. Now if I put this through a certain type of let's say a chevron is basically those structures. If I put through certain types of turbine blades, this is how air mixing happens. This is how fuel and air mixes, and this is how it can give us power, or it can give us torque, in any terms you wish to define it to. So that is developing the application for it. Both of these stages in a way are very basic, but they give you the understanding that you need. Once you have the technology concept validated, formulated, then you go for experimentation, analytical experimentation, to develop a proof of concept. And for that, you study different ways to harness it. Now if you look at the same technology of developing a jet engine, the most important part is definitely the components that you put inside it, because the theory is there. Modulate the airflow. That is things. You either put in enough turbine blades and infrastructure around it, chevrons and nozzles around it. It can manipulate air and fuel flow, and then also drive air out of it. So you develop your proof of concept to allow you to do that. So this is where you're. Sorry, can you see me? Sorry, it says bad signal. Anyway, so this is where you develop applications that allow you to harness the technology that you have researched so far. Once you're through that, you prove it in your laboratory model. That is, in this case, you build it at a lab. You make a small prototype out of it, or a proof of concept out of it, and you test it in a lab and make sure that it is working. All the CFD analysis is done. Once you have that, do it in a relevant atmosphere. You do a model test. In jet engines case, you put it in a full laboratory where you can simulate a full body through a computational fluid dynamics. Then you build a subsystem for it. You test it in different atmosphere. You test it for different conditions. In this particular case, you test it for acoustics and aerodynamics. Once you have done that, you validate it in real flight conditions or in real condition, that is level 7. If you got the level 7 done, then you go to level 8 where you actually deploy it. Or this is where what we actually call prototyping. That means you put technology, you can also call it advanced prototyping, but it is deployed and actually tested somewhere, and you start getting a certification for it. So that is the level 8, and level 9 is actually deploying it. So now if you see, we have gone all the way from a very basic study of fluid physics to developing an engine, and that is what TRL scales are. So if in case, let's say you are working on any innovation, any type of startup, a technology backed startup particularly, this is what you should figure out first. Okay, what are your 9 levels going to be? What are your technology readiness levels going to be? These technology level readiness level, if you define it early, will help you determine what direction to take. Otherwise, a lot of people start with a basic research, but they do not know how to apply it or where to take it forward to. You could also start by thinking, okay, you know what, you want to build this, the engine at the end, and you got to figure out level 1 to 9 for it. The approach, the final outcome of it can be defined either way, but you got to have it figured out all the 9 steps, even at least at some level right at the start. With that sorted and out of the way, in NITI Aayog and Atal Innovation Mission, we've particularly been working on different scales that can go beyond TRLs. So we've been studying what can we really do in terms of improving companies' profitability or increasing the chances of their uh, success. Then we measure things on levels. Instead of technology readiness level, now we have a evolved parameter, and this we call we haven't given it a name really, but we just call it innovation readiness level. The first thing is product readiness level. Under product readiness level, we look at if the product is ready, just like how you saw technology readiness level at a scale of 1 to 9. We have our own scale in each of these 3. So if you're good on product, if you're good on company, and if you're good on commercials, your company is bound to succeed. So these 3 things largely cover everything that is related to a technology backed intervention, technology based innovation company succeeding. Let me go a little deeper into it as well. So product readiness level, as you can see here, has different stages to it. We say ki this is quite similar and adapted from the TRL, but it is broken down to made a little simpler. So this helps you determine ki where do you really stand and what should you be doing next. If you're starting off, let's say at a lab POC, then you should be worrying about your prototyping. If you are at prototyping, then you should be worrying about where do I deploy it, where do I put it in a ground so that it is actually working and feasible, and whatever you're claiming is actually coming out in real situations. And fourth stage in this is quality validation, because if you really are out there to get investments and raise money and sell products, then QA, that is validation and certifications, is one of the biggest hurdles. So getting it sorted, or at least knowing what certifications to apply for, will save a lot of time for you. For example, a lot of startups, at least now, have been exempted from a lot of certifications, but a lot of certifications still exist. This could be technical certifications, this could be other types of certifications, but it is good to know what you are going to get into. Let's say if you're building a healthcare and medical device, they need to figure out, okay, what are the approvals that you need to get from ICMR, what are the approvals that you need to get from Ministry of Health, different agencies, what are they doing and all that. And similarly, at last you have your production ready design in the product readiness level. That means you are ready to manufacture. You have figured out, and if not manufacture, you're ready to produce. So if you are ready to produce at least the first few samples, how are you doing it? Have you figured out the design that will go into, let's say, have you figured out the computer simulation that will go into running it? Have you figured out the machine parts and design that you can give to, let's say, a OEM and ask him to manufacture it for you? So that all goes under product readiness level. Next is company readiness level, where we just talk about that product is never enough. A very good product in a bad company is not going to work. And company here encompasses both the legal aspects of things and also the human resource aspect of things. Human resource, because team is very important. So we say ki team building, team tie-ups, if you don't have a team built up already, is very important in this aspect. Again, this has been broken down further for your understanding, so I'm not going to readings of each, but this in a way is also considered, this is also in a way evolutionary. So you begin with you begin with company registration. You ensure that you at least have the basic minimum registration, you have your full team, you have your business planning and investments figured out. That will prepare your company for the next leap, or it will prepare your company through the journey. With that, I'll come to the last, which is commercial readiness level. Commercial readiness level is an indicator of your market success. So we are trying to understand different aspects that will determine ki, have you done your market study, have you done your production study about who's going to manufacture, how are they going to manufacture, have you figured out cost estimates of each of the parts of that you're planning to build. So and if you're going to build something versus build versus buy decision, all this comes under commercial readiness level. So and last, product market fit. So if you even if you have your product figured out, is there someone ready to buy? Have you done that studies? Have you figured out all the places where you can possibly get a pre-orders, or you can probably get a purchase order, and all the decisions. So this covers commercial readiness, covers all this aspect. Some of the key aspects of this is that customer development begins right from the start. So the things that you see on top are usually graded that way. It can also work in parallel, but it is recommended, let's say if you begin with customer development, you begin by achieving a PI. So PIR, which is mentioned here, is product innovation readiness level that we try to calculate. Alex say I don't have it here projected on this. That tries to understand whether you have done your customer development study. That is, have you spoken to 100 consumers? Are they ready to buy your product? Are they okay and in agreement with what you are trying to sell? So all this determines your PIR score, and higher PIR score that you have will give you a larger validation market and will reduce your risk much later. At least that you know once you manufacture the product, somebody is there ready to buy it. So this covers the three aspects. I'll share this with you. In fact, after this presentation, I'll share a small link for you all to fill in, so that if any of you require and want further guidance about this, we can discuss this further and probably connect you to people who can work with you. But this, if you cover all these aspects of things, which is product, company, and commercial readiness level, then you're more or less sorted to navigate this. Sorry about this. The commercial valleys and early stage valleys of death. You first begin with early stage of valley of death, and then you navigate commercial, like in the same order. But going stepwise and making sure all these steps are covered will naturally make sure that your valleys of death are not your fundamental roadblocks. So with that, let me come to the closing of slides. With this, what we do is, like the scale that I showed you, the CRL, CORL, and PRL. Like this is sort of like a information that you probably shouldn't know, but it's okay. I think we look at all these parameters, and then we try to categorize each startup into type of tracks that it can go down to. So not all startups are going to score equally. For example, if you score very high in, let's say, PRL, very high in CRL, and very high in CORL, which is product, company, and commercial readiness level, then you will be put on an acceleration track. That means your company does not require incubation and all that. You just require money to move ahead and scale fast. So there's no point saying, here's a grant, but you go to an incubator. For the acceleration track, the decisions are very different. We tell them, here's the money, now we will shut up, you do your thing, because we know they are that far ahead. So second is incubation track, where we look at all this, and let's say if you go in incubation track, it's likely that your product is not ready, or it's at medium level, your company is at medium level, and you're at commercially you're medium or low. And that would determine that it's better to send you to an incubator, where we give you the money, but we don't give you money directly. We route it through an incubator and tell you, here's the money, but to access this money, you should report to incubator and get your tasks or your plans validated and done in the same order that we are recommending it to. It reduces our risk, and it also ensures that the incubator is there monitoring your progress. This is only because we think the company is not ready yet. And the last stage of this is entrepreneur in residence, where we think the banda is good, the person is good, but the company is not ready yet. And that is why we are like, the entrepreneur is required, but the company needs to be built upon further, or the product needs to be built on further. And there's a different track for it. It's called entrepreneur in residence. There are very few startups, incubators in this country that do an entrepreneur in residence, but there are a bunch of them. So this ensures that we are sending, or we are validating startups on 3 different parameters, and basis their scores, we are diverting them to the infrastructure that will correctly support them. And in fact, it's not, although I did show you a jet example, but it's not rocket science either. So it could be something that all of you can validate your startups with and see where you stand, and depending upon that, approach wherever you think. You don't require government to do this. If you think your company fits in everything, go to an acceleration. Don't even think about it. Don't even think about wasting your time in incubation, be it anywhere. But if you lie in incubation, or if you lie below that, then ensure that you go to the right channel, because sometimes if your company is not ready, the incubator is also not going to take you, because incubation is a serious business. You can't go to an incubator and expect the incubation to babysit you, to walk you through the entire process. That is not going to happen. So you maybe are at a step lower, if you are lower in scale, to go to a incubation model or an entrepreneur in residence model. Nowadays, thankfully, the market is opening up and a lot of companies are offering entrepreneur in residence. The most recent example I remember was from Chayos. Chayos, the brand of tea stores that they have across India. They were opening up positions for entrepreneur in residence, where they were inviting people who have entrepreneurial backgrounds, who want to do entrepreneurial activities. They would give them a platform to work on their problems. So that sort of a program is entrepreneur in residence. That means you need to learn little more about innovation. So my request would only be very simple: take the framework, run your solutions through it if you think it's usable, and see where you stand. And depending upon where you stand, you can either go for let the key agent help you out. And if you require our input or support, you can reach out to me, or you can reach out to SRM Incubator, which is doing, I think, a great job anyway. So this is my last. This is just to give you an overview of what you can access right away and what Atal Innovation Mission also offers. Like I showed you, there is innovation cycle begins with idea and research and goes all the way to large commercialization, and we try to intervene at different stages. For example, for ideation and research, and for ideation, research, problem identification, and all that, we try to go with the phase one. That means we try to go and intervene right at the school level. We have built so far close to 9,000 schools. We have built labs in 9,000 schools across India, which are called Atal Tinkering Labs and Mentor of India model, through which we try to build we try to bring in that innovation curriculum to schools, and we give the lab there itself, so that you can go there and tinker with your ideas. You can figure out how things work, see things in motion, and all that. So we try to do that early. Beyond that, from tech development and POC stage, we try to take people in through programs like incubation centers, which we call Atal incubation centers, or established incubation centers, and also through a new program that we are currently coming with called ACIC, which you can see on top, Atal Community Innovation Centers. These are just being scaled up, so there are only, I think, 25 in the country right now. But these are supposed to be in all parts of India, including rural India, where people have ideas but they do not know how to pursue along with it. You guys are still very privileged because you have a college and an infrastructure. So this is Community Innovation Center supposed to address that gap, where people in areas which have not seen innovation are left behind because of lack of infrastructure. So people can go in there, learn, prototype, get some initial money, like initial sum of money less than a lakh, so that they can build their prototypes, launch it. And if they graduate, we push them to incubators, because like I said, incubation is a serious business. Incubation itself is supposed to be run like a private company. So if you go there, the incubation should also see profit out of it. It's not just incubator offering you all the support. Then we run two funding projects. We call them Atal New India Challenges and Atal Research and Innovation for Small Enterprises. These are challenges. That means it's a grant-based challenge where we float a problem and we tell you, you know what, this is the problem that the government is facing and is unable to solve. If you have a solution that can address these problems, come and tell this to us, and we will give you some money to develop it, and we'll also give you a pilot opportunity. So the money part of things is what alludes a lot of startups. Atal New India Challenge, for example, offers up to 1 crore for each startup if your problem addresses the right solution. But the money is given on the evaluation framework that I've shown you before, and is given in tranches. That means depending upon you achieving your milestones, your money is released to you. It's a grant, so no money is requested back from you. It is given to you with the confidence that you will achieve the milestones. Similarly, Atal Research and Innovation for Small Enterprises Arise is another program of Atal Innovation Mission, which is supposed to take problems from small industries and float it to startups, and the startups can solve it and the money can be given as a grant model again. But here the product is deployed not in ministries or departments, but directly with the the departments or the micro enterprises that are participating in it. So these are two key programs. Other than this, I would also like to add there is one very interesting program run right now called IDEX, Innovation for Defense Excellence. Apologies, I think that slide isn't come here yet, but you can look it up. IDEX is open throughout the year. It's called IDEX. Let me just type it out somewhere. And the IDEX program ensures that it opens up defense for. Sorry, I don't know if you can see my screen. Okay, so sorry. IDEX model similarly works with defense and ensures that the defense has the required startups that can help them achieve the goals that they want. And they do the similar model where they fund startups on a very similar framework, and they try to if your product works and it is delivering upon the promises, then it is usually incorporated or bought in by defense directly. One of the SRM startups, by the way, is a IDEX startup. It's called Big Bang Boom, which I think they work in ballistic technologies, and they have done a wonderful work. They are an IDEX incubated or IDEX funded startup. So there are ample of opportunities. In fact, after this, let me share some resources with the department also, and let me share a form right away that you can fill in to know more about all these informations and challenges that are available. My tip is if you guys are interested into certain domain, let's say if you are very interested in agriculture or something else, then go directly and search for these, because most of these departments have gotten very good at social media nowadays. So it's not like if Atal Innovation Mission or NITI Aayog is doing something you wouldn't heard of, you wouldn't see on the internet, or you wouldn't hear about it. It's likely there. So a little bit of searching will get you there, and there are so many that is coming up every day and closing every day that it's impossible to list a directory of these things. They come and go at random times. So my urge is to look at these programs, look at NITI Aayog, what Atal Innovation Mission is doing. There's a lot of content there. Look at Invest India, look at IDEX. These are the key areas where you can get a lot of material, a lot of support, a lot of funding also to help you get through the innovation journey. So with that, I will close my lecture here, and I will invite if anybody has any questions. I unfortunately have just 5 minutes though. So over to you, sir, and thank you so much.
Yeah, very good afternoon, Himansu. How are you? Hope you are doing good.
Good. I'm good, ma'am. How are you?
Yeah, I'm doing good. Thanks a lot for joining with us. I'm sorry I was little, late in joining that. Hope the session will be very useful for us. And we are having a few startups from the department also. For the very sure, we'll just come back. Even personally, also, I'll just come back to just take a head towards that.
That'll be great, ma'am.
Yeah. Thank you.
Sure. I'm just sharing a small Google form because I really want this to go forward. So I would request everybody who's on this call and whoever is interested in the innovation journey can fill this in. I will request only people who have some ideas to go ahead with this, because if you haven't thought about an idea, there's no point of seeking my help or anybody's help at this point. So I'll just float this for benefit of others. I'll just post it on comment section.
Any questions from the participants?
There you go. I have shared a small, it's a very simple form. Please fill in if you have. Probably shouldn't take more than 5 minutes.
Participants, now you can interact with the speaker if you have any doubts or any clarifications. Himansu, I have a simple question. I have a doubt.
Sure.
You said about the funding schemes, right, for the startups. So what is the basic minimum eligibility criteria to avail these fundings? Whether the team needs to have a prototype model or any proof of concept to be tested?
So it depends upon the type of the program or the goal of the program. Some programs try to start early. That means they fund pre-stage startups. That is startups that are at early TRL stage. But the funding is lower at early stages. At the same time, there are some basic criteria that I would mention is you should definitely have a company registration. You should definitely have a team on board with the technical details figured out, which we call the core details, core team that is required to build the product. So even if you see in our PRL scale, product readiness scale, we say the core team comes under that. And in fact, core team is as important as the product itself. So there are two things that we say in essence: get your team right, get your core team right, and get your team registration right before you come for a funding. Because if you don't have a registration, whom do we really give money to? Like you can't give it to Himansu or someone else. So it's no individual money that is allowed. So that's two things that is basic.
Okay, thank you.
Himanshu, in connection with sir's thing, we have an idea, of course, in terms of patent grant we are having. We have a registered company now with us. Yeah. So now, are we eligible, or what would be the next stand on taking ahead? Actually, we are in that stage now. We have a patent grant. We have registered for the company and all. Now we are just looking for promoting our product. Or in terms of, so in what way we are stuck up, how to just go ahead with this?
So you are caught up in the classic case of second value of death, which is commercialization, on the graph that I showed you.
Okay.
That is because you still need a plan to market it. So you don't have a marketing plan most likely, or you don't have a go-to-market strategy. So you essentially, we can get into elaborate details about it, but you got to figure out what do you want to do with the patent first. Do you want to build a technology product that is actually that's something that the market wants? So having a patent is a good indicator of innovation, but in no way it is an indicator of your market success. So it is not necessary that you will succeed. So you need to figure out if you want to go this route of building a product, building a team, and then going about commercial route, or do you want to give patent to someone, license it out and go the royalty way? Because a lot of people do that also. There are patent houses which essentially just roll out patents day after done another, and they get royalty for it. That is also a business model, not a very common one, but it is. So there are two models for you to figure it out, and once you have taken a decision, you can explore either of it.
Okay, actually we are in touch with the market analysis here, and as you're suggesting, that's what we are planning to move, like whether even like they were just talking about the two streams. So how we can actually just go ahead, or how we can pick one, because they were saying like they can connect with us in both the ways. So that's what I think you understood the dilemma what we had. We are in touch with the market analyst, and they are showing both the streams, and they are saying, you just let us know, we will just take up in that way. This is what in that way they are supporting us. So we are in a dilemma now. If you can just.
My general opinion is, ma'am, before you go to a market analyst, do your own study, because market analysts have to make their own profit. So they will try to take you into a direction that works for them as well. But before you go to them, some of these study you should do in-house, especially understanding what is your sizable market, what is the approach that you can take, what is the different channels through which your customers can come on board. All that decisions would have to be, all that research has to be done in-house. Without that research, you don't go to a market analyst, because then you're basically offloading your work. Like, if I have to say boldly, I would say only half of the work is technology development. In fact, not even half, it's 1/3 of the job. Because if you look at our scale, PRL has only 30% weightage, 33% weightage. Remaining company and commercial readiness has 2/3 of the weightage. So if you don't have the company and commercial, you are only at 1/3 of the entire entity.
Yeah.
I'm so sorry. I have to unfortunately
it's okay.
run.
It's okay. It's okay, Himanshu. For the very short, we'll come back to you, for your suggestions and all. Sir, Joseph, sir, over to you, sir.
Yeah, yes, madam, yes. So any other questions, participants, please?
No, sir, I unfortunately will not be able to take a question, but I will request everybody to fill in the form so that I can connect.
Okay,
thank you very much. Thank you.
Thank you so much, ma'am.
Thank you, sir.
Okay, thank you, Himanshu, for your time. We appreciate you for taking out time from your busy schedule to provide us with the valuable information. So hope our students are enlightened with your knowledge and message. on TRL and funding schemes. Thank you. Thanks for joining us.
Thank you, sir. Take care. Bye bye.
Thank you. Thank you.